Now, as an example, we are taking a pure metal, any pure metal, right? Aluminum, copper, any metal. And we are assuming that it is at a very, see, this is temperature and this is time. So we are assuming that it is at a very high temperature, much above its melting point. Because you see here, it is freezing temperature. What is the other name? It is melting temperature, isn't it? It is the same thing. If you heat it, then the liquid, right? If you heat it, solid will become liquid at this point. If you cool it, liquid will become solid. So if you cool it, it is called freezing temperature. If you heat it, it is called melting temperature. It is the same thing. So now it is at a high temperature and you start cooling it. So time passes, temperature goes on going down. So this is a cooling curve until it hits the freezing point, right? It hits the freezing temperature, right? It hits the freezing temperature. So it starts to become solid. Once it starts to become solid, you know, right? The temperature will remain constant. It becomes more and more solid. So here it was liquid. Once you hit this, there is liquid and some solid. And as time goes on, the solid becomes more and more, the liquid becomes less and less, until a time comes when all of the material has become solid. The temperature has not changed, isn't it? The temperature was going down, down, down until you hit the freezing temperature. And then with time, more and more of the liquid becomes solid until all the liquid has become solid. After that, if you have more time, then the temperature again starts to drop, right? So this solid line, here to here to here, this is the cooling curve of a pure metal. Forget about this dotted line, right? We'll explain it some other time. So if it is at a very high temperature where it is completely liquid, if you reduce the temperature will keep on reducing with time until you hit the freezing temperature, when it will start to solidify. And now the temperature cannot change. It will keep constant until all the material has changed into solid, and then it will start to reduce the temperature again. And this region, if you remember, there is the latent heat, right? Remember that temperature is not changing even though the heat is changing. So this is the cooling curve of a pure material. Now we take the cooling curve of a pure material, but
on the next page in the figure, we will be showing you the cooling curve for pure iron this time, pure iron. 1 atmosphere pressure means the normal pressure, at the normal pressure, right? So we earlier said any pure metal. Now the pure metal is iron. We are taking its example especially because if you know, iron is one of that, that remarkable metal which has 3 solid phases. So you will see when you go to that figure that at the freezing temperature, when it is molten, plus 1600, plus 1700, then when you bring down the temperature at 1538, the first time a solid appears. But this is a high temperature solid of BCC structure. This is called delta iron. So once from 1650, 1600 and so on, you drop down the temperature at 1538, the solid that starts to form is delta iron and it has a BCC structure. Then it keeps on dropping and more of the material is solid, but there is still a lot of liquid there. Once you hit 1394, another type of solid starts to form, which is FCC solid, and it is called gamma iron, right? The name is polymorphic transformation, polymorphic, because you are doing one type of solid, then the other type of solid, so it is polymorphism. So the liquid that was there, some of that liquid has changed to delta iron. Now below this temperature, some of the liquid has changed to gamma iron. If you keep on cooling down, some liquid is still there. When you hit 912 Celsius, then the third solid starts to form, which is alpha iron and which has BCC structure. So the top one delta iron BCC, the second one gamma iron FCC, the third one alpha iron BCC, and the temperatures are 1538, 1394, 912 and so on. So this is what we will show you on the next page in the diagram.
Our famous pure material. Which one? Of course, iron. but pure iron, right? We have not mixed any other material in it. Now, why is it different than the previous one? You understand, it has different solid phases. You see, water had only one solid phase. So when water was liquid and you cooled it, it became ice, and it started to become ice, and the temperature remained constant until all the water became ice. But here we have iron. So you see, if we are at say 2000 Celsius, 1600 Celsius, 1800 Celsius, it is superheated liquid material. Of course, if we go to 3000 or something, it will become vapor also, but let us take only liquid. So here at 1800 degrees Celsius, for example, it is liquid, totally molten iron. If you reduce the temperature keeps on, right? This is time again. So as time goes down, the temperature goes until it reaches 1538, which is the melting temperature. So at this temperature, it starts to become solid, and you know it is delta solid. And the temperature remains constant, time goes on more and more and more. So all the liquid has changed into delta solid by this time. Once it has become totally solid and you spend more time, then the temperature starts to drop again. Temperature starts to drop until it reaches 1394. At this temperature, the delta solid starts to turn into gamma solid. So now as more time goes on, more of delta solid is changing into gamma solid. And it keeps on doing until all of the delta has changed into gamma. Once you are here, it is purely gamma solid. Now, more time, then temperature again starts to drop, because here it is only gamma, and goes until you hit the temperature of 912. Once you hit that, then gamma starts to change into alpha iron, that you know. So as time goes, then more and more gamma changes into more and more alpha. Temperature remains constant at 912, keeps on happening until you reach this completely alpha phase, right? So all the liquid has changed into delta, then delta is changed into gamma, then gamma is changed into alpha. So at this point of time now, all the iron that we had has changed into solid alpha phase. After that, it is a solid alpha phase, and the temperature starts to drop until you become room temperature, and it still remains alpha. So you see, this is the cooling curve of the pure material iron. Liquid phase changes into solid delta, changes into solid gamma, changes into solid alpha, and after that it drops down to room temperature, and that is it, right? Why are we studying cooling curves, right? This is, you remember, a famous question of mine. I keep on asking you that you understand the cooling curve now. You understand the cooling curve of a pure material, which was on the previous slide, and the cooling curve of a pure material like iron, which has several phases. Why are we studying cooling curves? If you remember from chapter 1, we have been telling you how do we get metals, right? Famous question. The answer you already know, that we go into the earth, we go into a mine where we know from geological studies that we have iron ore inside there. So there will be iron metal mixed with rocks and so on, and that is called an ore. So you will do mining, you will bring out that ore. Now you will go to a factory which is called a steel mill. There will be huge furnaces. Before putting into the furnace, you will crush the rock so that the iron and the other materials mixed together are crushed into small pieces. You will put them into the furnace. You will heat it to such a high temperature that everything will melt. Then you will do some chemical reaction. You will add certain materials so that whatever other materials were there apart from iron are ultimately removed, and in the end you have pure iron there. And then you will cool it, and once it solidifies, you will solidify into a mold which is a rectangular shape or a square shape or a round shape. So you will have a bar, or you will have a round bar or a cylinder of iron, and so on, right? So this is how you make every metal, iron or aluminum or copper. You take the ore, you crush it, you melt it, you do chemical reactions, you purify it, and then you cool it. right? So you have the metal at a very high temperature where it is molten, and then you cool it until it solidifies. This is how you make every metal. So that is why we are studying cooling curves, that this is how we prepare metals. And if we prepare metals like this, then this is how we will change the properties and so on, isn't it? So therefore, we are talking of cooling curves. So in this chapter until now, initially we just were talking of the phase diagrams. We talked of the phase diagram of pure water and pure iron. Then we talked of mixtures, right? Mixture of sugar and water and so on, and mixture of aluminum and copper, and therefore solubility of phases, right? Because this is now not pure material. A mixture is two materials or more mixed together. And then we were talking of the cooling curves of pure materials. In normal pure materials, there will be one horizontal line from liquid to solid, but in things like iron, there will be several cooling lines, right? What do we have next? Now there is a topic of binary isomorphous alloy systems. So this being your first lecture after getting back from a big break, so today you are lucky. Normally at this time we will take a short break, right? And we will give you a small mental break and so on. Today we stop here, give you a full break, and now when we stop, there will be enough time for you to go back to the lecture and revise it and so on. We will announce some technique or some time how you can ask me any questions and so on. Right now, you can write me an email and so on, and then we can maybe talk. But I will experiment with some online softwares where I can set aside some time for you, where all of you can join me at the same time, so that if any one of you asks a question and I answer, then all the others who are also joined in at that time will share the answer, so I don't have to explain the same thing more than once, right? So this is it for today. We will keep on posting more lectures to your Moodle website, and from there, of course, you already have seen that I have put the lecture slides of the whole chapter of phase diagrams, so you have that, and together with that, these voice lectures where I explain this a bit will also be there. So this is it for today, and we'll see you inshallah. Assalamu.